Hey guys, thanks for tuning in. Today we're going to unbox and set up the Artillery Sidewinder X1. So it is labeled fragile, be careful. We've been told by our rep that this is the version 2/3, so the newest version available as of the time of this recording. Some additional corner cardboard here. All right. So, as is pretty typical, we have the entire gantry assembly there. Some paperwork, read me first, I'll read that later. There are some more instructions in a little bag. And then a nice little pouch, seems like assembly tools. Brackets, power cord, and then the base. Just make sure that while you're lifting this, the bed doesn't slide rapidly forward or back on you. There we go. So the Read Me First document was just a bunch of hazards. You can get burned, for example. They say you should be 18 plus to use this. This other sheet here was kind of nice. It's a QA checklist of every component. They checked it for scratches. They checked the X carriage cover. They make sure all the fans were working. It says dry run there. So that's kind of neat. I haven't seen that in any other boxes we've opened. We have the manual itself and probably a warranty card. And then I was right that in here, there's going to be the assembly tools. This is actually kind of nice to keep everything together when we're done putting it all together. So you've got your Allen keys, you have a wrench, and thin ribbon cable. Some spare wheels, actually just the Delrin part of the wheels. A couple bolts, that bag is broken, so just be careful. A tiny 3-color LED, USB stick, and more ribbon cable. Kind of throws me off that they're bundled into these nice little coils. All right, I'll move that stuff aside. The base plate here is very familiar kind of layout. They're using a very large rail here. It's not a 2040, but not quite a 2060. Kind of interesting, and they run the belt down the side. It's got the kind of textured glass surface that PLA seems to stick to very well, as long as you're running it really hot. Touchscreen on the front, full USB port, and micro SD on the top here. And then we'll bolt the entire gantry assembly through these two spots here. Just going to take some of this wrapping off first. So be careful when you're pulling off that wrapping. Some of it got stuck along the sides here, and this is a 110 volt AC heated bed. So this thing has the potential to get very, very hot. That plastic would not stand a chance. So just pay close attention, especially around the edges there. As I was mentioning the full-size USB port here, there's also a USB port here for a printer style USB cable. So the bed itself, you can see there's been a test print done in the middle, and on the corners you can kind of see these metallic pads. That's maybe where the bed has been bonded to the actual motion assembly there. I'm not entirely sure, but we'll figure that out together. The cables for the motors and limit switch, they're taped down. Everything's nice and secure. On the upright assembly, everything is zip tied so that it doesn't move around. So the hot end wouldn't be able to move side to side. There's zip ties kind of securing everything here, so we're going to have to cut all of these free before we go much further. So I went to cut the zip ties off and I realized there was no snips in our package. So I went and grabbed some snips. But before I cut those off, I'm actually going to bolt this onto the base and then release those. So as I typically do with this type of format, lay it on top, line everything kind of up. It just falls almost into place. Make sure we're not pinching any wires. There we go. And then I'm going to move the printer so that one side is hanging off the table. Be very careful. You don't want it to go falling on the ground on you. And then I'm going to take these M4x45s with a lock washer on them, 2 for each side, and bolt up from underneath. All right, the first side's done. And don't tighten them 100%, just in case you need to make some small adjustments to the alignment to get these two in. We'll go back and tighten those down fully. All right, just give these one last quick torque. So now I can cut all these straps loose. Be very careful because there is a ribbon cable that runs along here. There's also a ribbon cable for the Z on the side there. And that's really nice because then you don't have any cables kind of protruding from the sides of the machine. Gives it a nice compact and clean look. So now we've got the ribbon cable free here. There's a loose end that was taped to the side there. Just tuck that back for now. But first, we're going to put the spool holder on the top. Flipping this guy around, we're going to cut these 2 brackets free. And there's a filament runout sensor that is attached to a little standoff off of one of these spool holders. It rotates like that. And it's got a direction. There's an arrow facing down. And the filament runout sensor is going to be facing the front of the printer. So this big bulgy part is going to go on the back. And they're going to bolt on something like this. You can see there's these T-nuts. Some of them are obscured by this little guy there. There we go. So those T-nuts are what we're going to bolt through. And we're going to adjust it for our spools. In this bag of these small screws, there should be enough screws to attach it to those T-nuts. So I'm going to turn this a little bit towards me to make it easier. And we want to make sure that the bearings are facing inward, so facing towards each other, so that the spool holder the spool can sit on the bearings themselves. So let's grab one of these guys. It's nice that they're not hammer nuts, so you don't have to worry about them rotating on you. These types of nuts, these ones in particular, can only be inserted right from the ends of the extrusion and slid down the channel. You can't put them in after the fact. There are spring-loaded ones that you can, but these are not those. And I'm not being too picky on exactly where I put this right now. I can very easily just adjust the location at the end. There we go. This little guy that's getting in the way is for the filament runout sensor. As I'm screwing these in, one thing I've already noticed is that the dual Z rods are linked here with this belt, but this belt is very, very loose. It is a closed loop belt, so there's not much we can do as far as adjusting tension on that. Some of them have like a little piece in here where you can have another bearing that sticks out to apply tension to that. But it's really just to try to help you keep the x-axis level so that one side doesn't sag, and they kind of have to be adjusted and leveled out. So it's not absolutely required. It's kind of a nice to have. So if it does slip a tooth or something, you've got other major issues going on, to be honest. Okay. It didn't come with a spool of filament, so we'll grab probably some of our neat filament and throw that on here for our tests. So the instruction manual actually shows the plug for the filament runout sensor coming in the side. Obviously, in this case, the arrow is currently pointing down and the plug is on the top. So we're going to need to plug this cord in the top of this. There we go, like that. Make sure that this is pushed back in, which should kind of keep the, there we go, keep the cable secure. And while we're connecting cables, down at the bottom here, we have another ribbon cable that is still taped. And the other small connector there is for that filament runout sensor. It runs inside the channel here. So let's connect the other end of that guy. And then this ribbon cable should just slide in there. Now some of these have a little lever where you need to snap the lever to put pressure on these pins, but this just looks like it's a friction fit. There we go. And just make sure that it's even all the way across so that it's put in evenly. And we have the one Z-axis stepper motor here. And while we're at it, we'll do this one on this side. So on this side, we also have the end stop for the Z-axis. This is using a inductive end stop. Yep. And another stepper motor. And this end stop actually has a hammer nut on it. So we're going to attach it to the upright right here. And we'll have to loosen this hammer nut all the way. And we may need to adjust this later, so I'm just going to kind of tack it in place right now. And just make sure that the hammer nut has engaged, so you shouldn't be able to pull that out of the slot. I've erred on the side of caution. I put it awfully high up. I know the nozzle is currently above the bed. I want to make sure that when I home Z that it stops before crashing into the bed. So I'd rather, like I said, err on the side of caution. We can adjust that and bring that down later as we need. So I'm just going to check there we go, that this is the right width for our spools. Some people don't like mounting their spool on top of the printer. They feel that it introduces vibration into the system. I mount mine on top of all of mine, but also I have ball bearings like this. So it rolls smoothly, and then we'll feed it through the filament runout sensor. But we've got some assembly to do still. Down here for the Z-axis, we have another ribbon cable. Again, it's just friction fit. You shouldn't need to be forcing this in. You just want to be gentle with it. There we go. So while I was pushing down, the Z-axis did actually move a little bit. That one was a lot tighter than the other one. Okay, I'm happy with how that looks. We still have some tape on this stepper motor. So this is to move the X-axis. Pretty obvious where this guy goes. And that's connected with a nice beefy metal bracket on there. And then I think this is the last one. This would be for the entire hot end assembly. There we go. So since we're talking about the hot end assembly, we have a 3-to-1 geared Titan extruder, or Titan style of extruder. And underneath, which you can't see from that angle, but we have a Volcano hot end. So that's nice. We have a longer melt zone. It's good for if you're printing with really large nozzles and you need to make sure that that volume of filament is melted in time. Or if you're running materials that require extremely high temperatures. I'd probably throw a silicone sock on it just to shield it from the part cooling fan. It is a beefy part cooling fan. It's a what I would consider a proper part cooling fan, being that it's radial and not axial. And there's actually a little bit of filament stuck on that nozzle from the test print they did. Everything else is covered by this little shroud here. And looks like the tightening bolt for the extruder lever here to adjust the pressure. That's kind of difficult to get your fingers around, but you shouldn't have to be adjusting that too often anyway. Okay. Just checking all of the wheels. This carriage, as I mentioned, is a little bit wobbly. It's going to be nice and secure with a rail this large for sure. Better than it running on like a 2020, which is fine for some printers. Others, they have kind of tilting issues where the entire hot end wobbles back and forth on that 2020 rail. So the bottom wheel here needs to be adjusted. It has an eccentric nut on it that we're going to use that wrench on. And likewise, on the wheels here for the Z, the inner wheel has a eccentric nut on it, and we'll adjust those because right now these are just rolling free. We want to make sure that they're making good contact, at least as much as we can adjust in this format. So I'm going to move the Z-axis up to gain access to this eccentric nut on this wheel here. Obviously, you can do that on the screen. I'm going to move it slowly by hand. Normally, I would tell you you have to move both of these in unison, or at least as much as possible, to avoid that X-axis getting out of whack, as I mentioned earlier. But because of this belt here, you'll see the effect that it has. As I turn this one, it actually turns the other side equally. Not that I would recommend doing that all the time. I'm still going to try to do them in unison, but it helps keep them in sync. So with that up, underneath here, hopefully you can see that, like that maybe. So underneath here, there is an eccentric nut. We'll have to use the wider side, there we go. And turning it will apply pressure between this wheel, which currently spins completely freely and doesn't move the X carriage back and forth. As we turn it, we should feel that tension increase. There we go. You don't want to move it very much at a time. And right now, if I move any one of these wheels, oh, see this one's slipping a little bit. So a little bit more, and I'm moving it just a hair. There we go. So now, I spin any of these wheels, the entire carriage moves back and forth. There is no slop in that carriage whatsoever, which is exactly as I'd expect. There we go. We'll do the same with these wheels here. So this one is actually, all these wheels aren't too bad. You know, that one's not moving. But on this side, it's just spinning freely. Unfortunately, you can't see that. There we go. So this wheel here, just spinning around. So we'll want to do the same thing. Put the wrench on the eccentric nut. Move it just a little bit at a time. Sometimes you'll have to try both directions to figure out which way tightens. There we go. And now it's actually gaining traction, and both of these have traction. So as I'm wiggling the wheels, you can see it kind of jiggling up and down on that side. And then on this side. Good. I'm about to turn it on. I've plugged in the cable at the back. The switch is on the back. One last thing we should check before we try to really do anything with it is check the wheels for the bed. There are eccentric nuts on them as well, just like the other ones. Tighten them in the same fashion. They're a lot harder to get to. In our case, they are good. I've checked that, you know, I move each wheel and the whole bed moves. And also there's no play whatsoever here. So I'm ready to go. Powering it on, we have a color glossy touchscreen. I'm interested to see actually more details about the board itself. So after this, we're going to open the bottom and check it out. But for now, I want to just home all axes. I'm gonna home them one at a time, just make sure everything's working. I should mention that, you know, I was very careful with where I put this, made sure that it's going to stop the gantry from moving too far down and smashing into the bed. The manual does say you should measure 75 millimeters from here. I'm going to do it by eye and feel. So let's go to maybe tools, move. Oh, we could home, but if I go move, then I can do all the different directions. So let's go Z up. Well, that's a good start. Down, the Y moves forward and back, the X moves over and back. And I can tell right away, these guys are using trinamic drivers or something equivalent because it is silent. Just hear a little bit of fan noise from under the case here. Let's go back. Let's just home all. It's quite a quick Z home. Usually Z moves a lot slower. That wasn't time-lapsed at all. That's real-time speed. They've also decided to employ, like a couple other printers do, turning off the hot end cooling fan that blows by the heatsink. They've turned that off when the temperature is below a certain set point, usually around 50 degrees or so. So they don't need to run all the time, which is nice and makes the printer just that much quieter when it's sitting there idle. So let's check the bed and the hot end, make sure that those are heating up. So heat menu here. And so it tells me right now, extruder 1 is 21 degrees, currently set to 0. So I'm going to, oh, weird. Okay, so we're gonna add it in 10-degree increments apparently. So right now it's set to 110, we'll go 190. You can close it. I'm not sure if that means like cool it off. And there's also 10 degrees Celsius, which is, that's the increment. So clearly I'm looking at this for the first time as well. So we can change the increment in which we change the temperature. So 1 degree, 5 degree, or 10 degrees. So that makes me feel a little bit better. If I do close, it turns the heat completely off. So let's set that back. $190. And we can extrude only once we get above the minimum extruding temperature. Back in the main menu, we have change, so that's going to be rapid loading and unloading. And unlike a Bowden setup, this is direct drive. So the loading and unloading, we don't need to pull it all the way through a Bowden tube, 400 millimeters or something like that. We're just going to need a little bit to pull it out of there. If we go level, it's got set points for the different corners of the bed, as well as the middle of the bed that they call the 5th set point. So if we move it to the 1st set point, because we are quite a ways above the bed still. There we go, so it moves in a little bit. And of course, I've got 2 or 3 millimeters there where I need to adjust this. So what I'm going to do is turn off the machine. I'm going to bring the Z-axis down to where the nozzle is just touching the bed, and then I'm going to adjust this so that it's at exactly that level. It'll probably be around that 75 millimeter mark, and then we'll be able to continue with the auto bed leveling. So I've adjusted the end stop, and now the nozzle is just touching the bed, or just above the bed by a small hair. So we've already got the extruder up to temperature from before, but we never did set the temperature on the bed. Right now it's just 22 degrees. So let's go to Tools, and I would hope it's under Heat. So extruder 1 is 190. How do I go to the bed? You can toggle here, extruder 1, or extrude 1, tap it, now you're at the bed. Bed temperature is not set. We're moving it in 10-degree increments. So let's set that to 60 degrees, maybe 65. Okay. So we'll have to wait till that gets up to temperature, and then we will use our trusty QA sheet from before and just check it for level. We will use the leveling menu, move it to all 4 corners, and then double check in the center, and then we should be ready to do a test print if we so wish. So we had a little bit of temperature overshoot on the bed. It went to 67, but it heats super fast, so I'm not really gonna fault it for that. Let's go back to the leveling menu, and we'll go first again. I know we're already there, but just for fun. And so we've got lots of space. We'll just use the knob under here until we feel that drag. And we'll go to the next spot. Second. Third. And then fifth. Okay. So as per usual, go around once. You should do it a second time because as you change each corner, you're influencing the others. So I'll do one more round and then we should be perfect in the center. So I went around a couple times. The thing is dead level now. And this glass plate, the build surface here, is dead flat. So, you know, you've got a good stable platform here. You've got a flat surface. I know it doesn't have a ABL of any sort, but honestly, if things are stable and actually flat, not concave or anything, you shouldn't really need an ABL. It's kind of a crutch. It's convenient. It's nice to have. It saves you from having to really do this, but I'll hope that this stays good and level. Right now, it looks good. I'm gonna cool this off, and if you watch this far, you're gonna be rewarded. We're gonna turn it on its side, pop the bottom plate off. I'm sure there's a pile of screws. And we're gonna see what makes this thing tick. So let's first make sure we cool everything down. I'm going to go to heat and close for the bed, toggle it back to the hot end and close for the hot end. And then I'm just gonna watch those temperatures on the main screen here and wait until the cooling fan here turns off, which will tell us that that is all cooled down enough that we can just turn the machine completely off at that point. So I've turned it on its side very carefully, and I've got 1, 2, 3, 4, 5, 6 screws to take this bottom plate off, and I'm gonna have to cut this warranty seal, but I usually void my warranties anyway, so that doesn't bother me at all. You can see here where I originally screwed the M4 screws up through the uprights to attach that on there. And now I'll just go through the painful process of removing all these small screws. Okay, I got all the screws off. There's a nice big cooling fan here, which, you know, it doesn't have to spin as fast as one of those tiny fans. Careful, because there's not a very long lead on that, so you're gonna have to disconnect this from the board. There we are. So you have kind of the subframe. This is what the uprights are bolted to. You have your power supply, 24 volts, SSR here. The SSR is going to be for the bed. So it's going to be DC in on one side to trigger it and 120 volts switched on the other, or 110 volts switched. We have our steppers, and I am very curious to see what these guys are. So I ripped the heatsink off to try to see the label on the case of the chip, and there was a bunch of strange letters on it. Didn't look like a normal Trinamic chip, so I'm not sure what chip it is, but I don't particularly care because it's silent. I did have to replace the heatsink with a new one because I had to take all the thermal compound off. Place that guy back in there. So this board has a bunch of free expansion slots. It actually looks like a MKS Gen L. It says version 1.0, and I don't see any other labels on it, but it's got the same general layout. And then there's this kind of daughter board. So this board here is what provides the micro SD and USB for the USB stick. The MKS Gen L doesn't have an SD card slot at all built into it. It just has the printer style USB port on the side there. It also looks like there's a little buzzer. Nicely tied cables, you know, good cable management in here. The stepper for the Y-axis, that runs the belt that ran along the Y-axis rail. And then the daughter board here that we connected the ribbon cable into on the top side. They're using a SandLAN power supply, so it's not like a mean well, but that's also okay. And then just the ribbon cable for the TFT screen. That's really all there is to show about that. These rails are nice and beefy. This is a 40/40. This is a 20/40. So that's pretty substantial. I think that's gonna hold up well. So I'll bolt all this back together, making sure to connect that fan. So with that all back together, I've loaded the filament through the filament runout sensor and into the Titan extruder. And now I'm ready to start my first prints. Let's take a look and see how this turns out. So we're back. I've played with the printer a little bit and learned a little bit more about it. So it is running Marlin. It's 1.1.9, so that's nice. I would probably flash it again and maybe enable linear in advance and start tuning that a little bit. I did find the touchscreen cumbersome at times, specifically as it pertains to starting a print off the micro SD card. So I would have the printer on, I would insert the card, give it a couple seconds, and then I would go to the print menu and I would be greeted with just a black screen and I couldn't get out of that. I'd have to reboot the machine. Upon rebooting the machine with the card in, I had no problem selecting the print menu and going through the files that are on the root of the card. I also made sure that I had formatted the card as FAT32, 4096 sector size, or allocation unit size, depending on what tool you're using. So I knew that it was formatted correctly and I still had that symptom. In the end, I managed to do multiple prints without running into that on the successive prints. So I'm not sure what to say about that. I did a vase. So this is a good test of some height without taking an obscene amount of time. This was probably about 4 to 5 hours or so. So this is printed with the stock nozzle, which is a 0.4 millimeter nozzle, 60 millimeters a second. In Cura, I'm using spiralized outer contour, and I think I did 5 or 6 bases just to give it a little bit of weight. I mean, in general, it's fine. I'm concerned about this repeating kind of banding pattern that seems to happen about every 5 millimeters or so. And even within individual layers, I'm not sure how well the camera will pick this up, but there's almost like a textured effect, like a watery effect. There are entire sections, like right in through here, where it's smooth as glass as you would expect. And then just a little bit over, there's all this texture. So the texture didn't seem to be in line with the X or the Y directions. It was almost random. I went and double checked that everything was tight. I checked the belt tensions on X and Y as well. It didn't really make any difference. The interesting thing is that that effect only seemed to happen in the vases that I printed. When I printed a solid object, like this, or a little more solid anyway, testing out some rainbow PLA, I don't have any of that banding at all across the horse's body. So the body turned out great. What I was fighting with on this model was stringing. Using another printer, which has a Titan Aero, so very similar setup, I use about 0.9 millimeters of retract at 60 millimeters a second, and I have no stringing issues whatsoever. Using those same values here, I had considerable stringing, and I even upped the retract to 1.1. I tried lowering the temperature a little bit, but it's always a balancing act. You lower the temperature further to try to reduce the amount of stringing or oozing that's happening, and then you end up with adhesion issues at a certain point. But this one had a lot of strings and these little zits as it left each layer to move over here, say, to print part of the tail. I mean, all in all, it's fine. You know, I wish the entire print was like the side of the body here, but unfortunately that's not the case. So I'm going to need to spend a little bit more time learning the ins and outs of this machine. I may take part of it apart, specifically the lead screws on the Z, make sure that those don't have any kind of bend in them, that they're not warped. So just rolling them on a table, they should roll smoothly. So stay tuned, more to come on this printer. In general, I thought it was great. It was a great attempt. You know, it's very beefy. This rail is beefy, the top here is beefy. The dual Z being synced like with the belt is a great addition, especially if you're someone that fights with having your X out of level. But I think there might be a little more work to do here. Hopefully you found that useful. Remember to like and subscribe and ring the bell to get notified when we upload more videos like this one. Thanks for watching.